right. All right, guys. No more submissions, okay? It's already 3 o'clock. I heard that, I thought you got the message from, it seems that a lot of people are submitting last minute. I told you guys yesterday. Oh, shit, what's going on? And you guys had a good Easter?
Yes.
Yes? Did you go some interesting places or what? No? Oh. Hello? Did you guys have a good Easter or what? Yes or no? All right. Well, I was in Manchester all Easter, so I was just replying to all your emails. So I didn't get a chance to go anywhere. There are a few announcements. I'll try my best to mark all the courseworks. Although I constantly, like this morning, I was sitting on my chair for 4 hours, constantly marking. I still got to do the same thing this afternoon, after the lectures. I know about the UEQ thing. I know that there are still quite a few people who have not completed. I think there are about approximately 50. So, I mean, so please, if there are people here who have not completed the UEQ, please could you do so as soon as you can. You will not receive your mark unless you do so. Okay? You will not receive the mark later today. It might be midnight, I don't know, depending on how fast I mark things. Okay? Okay? There are a few things I wanted to talk about. This week is, by the end of this week, we would have completed the syllabus for the course. Right, so this week I will talk about, this is week 11, right? Week 11, we will talk about examples on one sample test. And also, we will also talk about two sample tests. Okay, but the two sample tests will not come in the exam, right? That's week 11. Now week 12, week 12 will be revision week. Okay. Right, next week will be the revision week, so there will be, I will depend on you guys to ask me questions, and I will answer the questions on the, on the visualizer, right? Okay, and the exam, of course, the exam is on your exam for Intro to Statistics will be on the 20th of May, which is less than a month away. Yeah. I know a lot of you guys ask me the style of the exam will be different from previous years, because previously this course was taught by somebody else, not me. All right. Now, did you guys get my email about the exams? Don't tell me you did not. I sent you at least 3 copies, 3 different duplicates of emails about the exam, right? Unless you delete all my emails, which is quite possible. There is an email I sent to you about the exams. So basically, what you need to know for the exam is contained in that email, right? And so all the material that you need to learn are basically in that email. So when you revise for the exam, you should concentrate on the scanned, on my notes. On my scanned handwritten notes, not the printed notes. The printed notes contains more than what I taught you, right? The printed lecture notes contains more than what I taught you. So I think it's not a good idea to use that to revise for the exam, right? I think I would suggest you use these scanned handwritten notes. Hopefully you can read my handwriting to revise for the exam, right? Okay. Now, one other thing I want to say is, all right, about the exam, because a lot of people, some of you seem anxious about the exam. I don't know. The exams will contain 2 sections, Section A and Section B. Section A will contain 4 questions. Right? And you will need to answer all 4 questions, so there's no choice. All 4 questions must be answered. So to the benefit of you, I'm going to tell you now what the 4 questions are going to be. Not exactly. If I tell you what the questions are, then you don't need to, you'll all get 100%, right? Question A1. All right, the question A1 will be on descriptive statistics. So it's the first thing we learned in the lectures. Is things like sample median, sample mean, quartiles, first quartile, third quartile, and so on, right? A2 will be on bias. Right, will be on bias, unbiasedness, mean squared error, consistency. A3 will be on test of hypothesis. In particular, I mean, only one sample test. I will only talk about one sample test because, as I said a minute ago, the two sample tests will not be examinable, right, for the exam. A4 will be on confidence intervals. All right, and again, this one sample. One sample confidence intervals, right? So that's section A. Now section B. Section B has 3 questions. It will have B5, B6, and B7. All right, there will be 3 questions in section B. Right, and you will need to answer 2 or 3 questions, any 2 of the 3 questions. Right. The first question on section B will be on will be on bias, unbiasedness, and MSA, right? And the second question in section B will be all right, the second and the third questions. They are both on one parameter MLE, right? I think we did nearly 10 examples on, I think, if I'm not mistaken, I did about 10 examples on one parameter MLE, and also about 10 examples on bias and MSA. Yeah, so you should have enough practice. You should have enough material to go over, right, in order to prepare for the exam. Okay. All right, guys. So this is the structure of the exam, and this is, if you compare with the previous year's exams, you will see it's different. It's different, right? So so the reason I've given you this is because to let you prepare for it, right? Okay. Just to let you know. Okay. All right, guys. Now, what I'm going to do in the time remaining is I'm going to do some examples on one sample test of hypothesis. Before that, I know it's 3 weeks ago, more than 3 weeks ago, we did one sample test of hypothesis. So I thought it might be a good idea if I just revise the material that we learned 3 weeks ago. Yeah? Because I know maybe, come on guys, you look tired after 3 weeks of break. Oh, what? So this is, this is test of hypothesis. Shh, can you listen please? This is test of hypothesis. This is H0, H1. H0 is the null hypothesis. H1 is the alternative hypothesis. Then there's something called the test statistic, which is a function of the data. And there's something called the rejection rule, taking one of these forms. And there's something called the rejection region, which is this one. Right? These are all stuff we did before the Easter break. And there's something called the acceptance region, which is this one. Right? And then we talked about this box here. This box basically tells you, right, on this axis you have the decision either reject or accept the null hypothesis. Here you have the state of nature, which can be either H0 is true or H0 is false, right? So as a result, you have two possible errors. The first error is known as the type 1 error, which is the probability of rejecting H0 when H0 is true. And the second error is known as the type 2 error, which is the probability of accepting H0 when H0 is false. Okay? So those are the two errors. And there's some notation which I talked about. This is alpha is the notation for probability of type 1 error. Beta is the notation for probability of type 2 error. And alpha also used to denote the significance level of a test, right? And then I talked about testing for population mean when the variance is known. And these are the three possible tests, right? There are three different sets of hypotheses, and these are the corresponding rejection rules, okay? And then I talked about testing for population mean when the variance is unknown. And these are the three sets of hypotheses, and these are the corresponding rejection rules. And then I talked about testing for population standard deviation. These are the three sets of hypotheses, and these are the corresponding rules, right? Here, use the percentiles of the standard percentiles of the chi-square distribution, right? And finally, I talked about testing for population proportion. And so P represents the population proportion, yeah? And you have three sets of hypotheses and the corresponding rejection rules. Okay, so this is what we did, if you remember, okay, I know it's a long time ago for some of you. So that's what we did 3 weeks ago, okay? Now, what I'm going to do today is to do some examples on the one sample test of hypothesis. Okay? Oh man, sorry. So let's start with, I can't remember the example that do you remember the example number that I did last? 5. Was it 5? Yeah. Okay, so it should be example. This one should be example 6 then. Example. I mean, I did 5 examples before the Easter break. So this is example number 6. Okay? Right. Suppose we are testing sorry. excuse me, just excuse me for taking your time. Right. So this is the question. It says that if you require that with probability that at least 0.9, the standard test will reject H0 when in fact the true mean mu is equal to 95, how large should n be? Right. The first thing, do you guys understand the question or no? Yes? So the question says the probability of rejecting H0, right, when mu is 95, yeah, should be at least 0.9. That's what it says, okay? We want this probability given mu equal to 95 to be at least 0.9. So the question is, given this, what should n be? Okay. Now, if you look at the formulas that I just mentioned a few minutes ago, if you look at the formulas, what is the rejection rule for the null hypothesis? This implies that do you see where this formula comes from? Where does this come from? Huh? It's just the formula that I just showed you a minute ago, right? Yeah? This formula here, guys, this one, right? Okay. Okay. Right. Now, because the true population mean is 95 and it's not 100, we need to replace 100 by 95, okay? So what I'm going to do is the following. I'm going to replace this by 95, okay? So I need to add 95 and subtract 100. Okay. Do you see what I'm doing? Okay. The reason I'm doing this is because I want to subtract the true population mean, which is 95, right? Now 95 minus 100 is minus minus 0.5, minus 5, all right? So if we take it to the right-hand side, okay? Are you guys with me so far? Yes? Right. Now, what can you say about this? This is something I talked about this morning in one of the example classes. I don't know. What can you say about the distribution of this? This is where I need the pen. Where's my pen? That's here. I don't know whether you guys remember this, that if you have stop writing. Right? If you remember, if you have a random sample from a normal distribution, right, then this implies that the sample mean x bar has a normal distribution with. Do you remember this result or no? No. This is one of the formulas you need to remember for the final exam, right? And which in turn implies that root of n divided by sigma times x bar minus mu has a standard normal distribution, right? Now I'm going to use this result. Let me put this in a box. Right? I'm going to use this result because condition on mu being equal to 95, because of this result, this must have a standard normal distribution. You follow me? Yes or no? Yeah? Okay, so what I'm saying is that because of this result, what we have is that it's the probability that a standard normal variable, yeah, is less than okay. Yes. Now we don't need the conditioning anymore because we have used the conditioning to argue that given the conditioning, given that mu equal to 95, we have argued that this has a standard normal distribution. So therefore we have used the conditioning, right? And hence, once we used it, we don't need it anymore, right? Okay. Okay. Yes. And this implies okay. And this implies that you guys with me or not? Okay. And finally, taking the square both sides, you have the answer. The sample size n must be greater than or equal to, if you square both sides, you get 20 divided by 25. Okay, so that's the answer. That completes example 6. Is that clear or not? Some of you seem lost. You guys okay? Your answer? Anything not clear about this? I mean, some of you feel sleepy. Well, how come after 3 weeks you are still sleeping? Yeah, is that clear, guys, or not? Yes? Okay. All right. So that's example number 6. Right, the next example. Example number 7. Is the following. Right. So this is example 7. All right. We are testing for this versus this with alpha equal to 0.05. The sample size is 35, and we want to find beta. Remember, beta is the probability of what? Type 2 error. Okay. So beta is right. Now, if you look at the rejection rule that I just gave you a few minutes ago, I told you what the rule for rejecting. I'm finding it here. Just a minute. Give me a sec. Where is it? I can't find it. Oh, I see it. It's here. Okay. This is the rule. You remember this rule here. When you test for sigma equal to something versus sigma greater than, the rejection rule is this one, right? Okay? Right? So the rule for accepting will be the opposite of rejecting, right? So it will be n minus 1, which is 35 minus 1. S squared, remember S squared is a sample variance, divided by sigma 0 squared, which is 10 to the power minus 4, less than or equal to chi-squared with degree of freedom 34 and 1 minus alpha is 0.95. All right, this is what you need to find. Okay, you need to find this probability. Okay, now, now this is where you need to use one of the things that we learned a long time ago. Do you guys remember that? Let me ask you this. This is 34 multiplied by s squared divided by sigma squared, right? And I'm going to divide and multiply by sigma squared, and then 10 to the power minus 4 we have here, less than or equal to okay. Do you see why I have done this? Do you know anything about this guy here? I know it's a while we did this, but we should know. You should remember what distribution it has. Do you remember what distribution this has? Yes? All right, good. All right, before I answer that question, let me take this guy here, this fraction here, to the right-hand side, okay? Okay. Now, if you look back in the lecture notes, I think this is one of the formulas you need to remember for the exam. I think I may be mistaken, but just check on the formula sheet. Okay, you know where the formula sheet is, right, for the exam. This guy here, right, condition on sigma, this guy has a chi-square distribution with n minus 1 degree of freedom, which is, in this case, is 34. Don't tell me you don't know this. I mean, it is in the handwritten notes and also in the formula sheet, right? Okay, that this has a chi-square distribution. Okay. All right, and so we are nearly done. So if you want, you can write this in a neater form like this. All right, here f denotes the CDF of the chi-squared variable with 34 degree of freedom, right? So that's example number 7. Now I know I promised you guys that I would do 10 examples on everything. So we got 3 more examples to find out. I need to fish out 3 more examples. Let me see if I can find some more. Oh yeah, here we are. Okay. Are you done with do you follow these guys or no? Hello? Are you happy with this? Anybody? Yes?
Why did you use a condition?
The condition is because condition on sigma, right? Sigma, we don't know the value for sigma. The condition on the true population standard deviation being sigma, this will have a chi-square distribution with n minus 1 degree of freedom. All right? So therefore, we have used the conditioning. All right? And therefore, in the next step, we don't need the conditioning anymore. It's not like conditional probability. I think this is not, you shouldn't treat this as conditional probability. It's a bit like saying that condition on a true population standard deviation being sigma, this has a chi-square distribution with n minus 1 degree of freedom. Hence, we have used the conditioning, so we don't need to put that conditioning anymore, right? Okay. All right. So that's example number 7. Now, example number 8 is this one. Example 8. Right. Okay. So we have a variable x that has a geometric distribution with parameter p, and we are testing for p equal to 0.1 versus p equal to 0.2. We reject h0 if x is less than or equal to 5. We want to find alpha and beta. Okay. Now let's find alpha. Now remember, what is alpha? Alpha is the probability of rejecting h0 given h0 is true, right? That given p equal to 0.1. Okay. So this would be remember, the geometric random variable is only defined from 1, 2, etc. It doesn't include 0. So the sum goes from 1 to 5, not 0 to 5. Okay? So this would be... Okay, now do you remember the PMF of the geometric? Is P times 0.1 times 1 minus 0.1 to the power k minus 1. So that's your alpha, and your beta. The beta is the probability of accepting the null hypothesis, so which is x greater than 5 when p is 0.2. Okay. Yes. So this would be you can use the complement rule, because if x is greater than 5, it can possibly take 5, 6, etc. up to infinity. So I want to use the complement rule and say is this, right? And this you can write as this. And finally, all right. Okay, guys. So that's the. So this is the value for beta, and this is the value for alpha. Is that clear, guys, or not? And this is, yes. So that's an easy one. Right. You have any questions on this, guys? Yes? No? You're right. Okay. The next example, well, we are nearly, well, I will give this as a homework, so maybe you should like homework, guys. I will give you this one. Example 9. Suppose you are testing this versus this, right? Right? That's the homework, guys. Now, on Thursday, I will talk about two-sample test of hypothesis, but that will not be examinable. So the material on Thursday will not be examinable for the final exam. Okay?
Exam, do we get given a formula sheet? Is there any formula sheet or?
No.
But there's a sheet that has formulas for me to learn.
Yeah.
Is it online?
It's online, yeah.
Yeah, I think I've
It's
seen
on
it.
the school, on my website.
Yeah.
Yeah. So it's first website. Yeah. Yeah. See you. Yes.
I don't understand why when you got to this bit you couldn't just like straight away. Wait, let me show you the other one. When you were trying to do the test to hypothesis and you had this, why can you not, because it's a geometric, just put 0.2 squared?
Yeah, yeah. You can do that. Yeah.
But when we did it on a calculator, we got a different answer. Because I did the same with this one, where I did 1 minus, and then it was...
I don't know the formula for the. I can't remember the exact formula for the CDF of the geometric.
I think that is it.
I know the PMF is P times 1 minus P, K minus 1, right? But I'm not sure the exact
You just have to
formula.
sum it up, I'm sure. Yeah, I think
Yeah,
that's right.
but you can check it online. You can check it online what the formula is. Yeah.
The other thing is, for the one type of test, do we have to? The rejection rules for the sigma are not on the sheet, so we don't have to remember those. Will you give us an example?